Welcome to aminacademy.com. In IB Diploma Physics higher level, let us do some example paper. Look at this. A car has an initial speed of 16 meter per second. It deaccelerates 4 meter per second squared until it stops. What is the distance traveled by the car? Here, S equal distance is equal v square minus u square over 2a. Final is 0. Initial is 16 square over 3 into acceleration is 4. So we have 32. 32 meter. So option C. A block of mass 2 kg accelerates from a speed 15 meter per second to speed of 20 meter per second without changing its direction. What is impulse act on the block? We know that impulse equal force into time. Now we know that mv, mass into velocity, is here 2 times final speed minus initial speed. Equal to 10. So this is 10 Newton second. Option C. Question number 3. A net force of 8 Newton accelerates 4 kg body from rest to a speed of 5 meter per second. What is the work done by the force? Here force equal half into mass 4 and speed the square half mv square over the distance. That is force into distance equal work done. That is here F equal to half into mass into velocity square by distance. And here 8 Newton is the force is given. Here it is 50 over the distance. Then here force into distance, that is 8 into 50 joules. So option A. Next question. Question number 4. A disk of mass m and radius r is on the horizontal frictional rest table. Two equal and opposite forces, each of magnitude f, act on the disk. The moment of inertia of the disk about its axis is half mr square. What is the angular acceleration of the disk? Here, two forces, opposite forces acting on the disk, equal forces. Then we know that torque is I alpha. I is moment of inertia, alpha is angular acceleration. Here the force F into the torque is F into radius. Here also F into radius. So 2 times F into radius to Fr equal I equal to half mr square is given into alpha. Therefore, alpha equal 4 fr over mr square, which gives this r cut 4f by mr. The option is D. Next question. A person stands in an elevator, that is lift. The total mass of the person and the elevator is 800 kg. The elevator accelerates upward at 2 meter per second square. Then what is the tension in the rope? Here the lift is going up. So we have the formula tension in the rope T plus force on gravity, that is mg, equal ma. Therefore T equal ma minus mg, m into a minus g, equal to mass is 800, a is 80 minus t minus mg here. Acceleration on lift is 2, gravity acceleration is 10. So 12 into 800, which gives 9.6 kilonewton. 9600 Newton, that is equal 9.6 kilonewton. Option D. Next question. An object is released from rest in a vacuum at a height h above the Earth's surface. As the object falls, it passes a point of height 0.75 h above the surface. What is the kinetic energy of the object from the height 0.75 h over gravitational potential energy of the object at the height h? That means an object is falling freely from height h. So we are comparing kinetic energy of the object with certain height, that is 0.75 height, by gravitational potential energy of an object from the height h. Here, which is equal, this kinetic energy of the object at a height 0.75, which is equal to 1 minus 0.75 h. That means this kinetic energy is equivalent to potential energy with 1 minus 0.75 h. Both are equal. Then over gravitational potential energy of height is, that is m g h, that is total height 1 into h, which is equal 1 minus 0.75 is 0.25 h over h, which is equal 0.15 is 1 over 4. Option B. Next is question number 7. A cylinder of mass m and radius r rotates at constant angular speed omega about an axis through its center. The rotational kinetic energy of the cylinder is K. That is, rotational kinetic energy is K given. The moment of inertia of the cylinder is half mr squared. A second cylinder has the mass 2m, radius 2r, and rotates with angular speed 2 omega. What is the total kinetic energy of the second cylinder? Here, the first cylinder kinetic energy of rotational is half I omega square. Therefore, which is equal to K, half I is half mr square omega square. For the second cylinder, K equal here this is 1 by 4 because half into half is 1 by 4. M is 2m, mass is double, and R is double, and omega also double, which is equal 1 by 4 m R squared omega squared. Here 2, here 4, 2 squared is 4, here 2 squared is 4, 4 4 are 16. 16 into 2 is 32. Therefore, this is 32K because 32 times more than the first cylinder. So option C. Look at here. A bird weighs W sits on the thin rope at its midpoint. The rope is almost horizontal and has negligible mass. The tension in the rope is, it won't be less than W by 2 because already mass of the body is W. Equal to W by 2 is also wrong because the tension is more between W2 by and W greater than W. Option D. Next question is spacecraft. A spacecraft moving with speed v relative to Earth passes Earth on its way to planet. As the spacecraft passes Earth, clock on Earth and the spacecraft shows 0. The planet is a distance d from the Earth according to the observer on Earth. What are the readings of the Earth's clock on the spacecraft clock when its spacecraft arrives at the planet? That means this is a relativity question, and that the formula here d by v is the distance. Actually, Earth clock reading is a d by v is the time. D is the distance over velocity is the time. Then spacecraft clock reading is same time into 1 minus the fraction 1 minus v square minus c square, where v square is the spacecraft speed and c is the maximum speed of the light. So this ratio we have to multiply with the time. So this time is spacecraft clock reading is slowed down this much. So this is the direct formula. A. Question number 10. The internal energy of the real gas is, it won't be 0, it won't be equal to the intermolecular potential energy to the particle, and equal to the kinetic energy, not only the internal energy is not only the kinetic energy, equal to the sum of the intermolecular potential and the total kinetic energy of the particle. Both together is the internal energy of the gas. Option D. Then question number 11. A gas undergoes one cycle of a cyclic process. A net change in internal energy of the gas is 0 because it is total. Therefore, gas undergoes the one cycle, full cycle there is the net change in internal energy is 0. Next question. A working refrigerator with a door open is placed in a sealed room. The entropy of the room. The entropy of the room is increased because the working refrigerator with the door open and placed in the sealed room means that entropy of the room is increasing because that cooling is supplied to the change in temperature is supplied to the room full, so it increases. Next one, a black body radiation curve of an object 600 K is shown, that is at 600 Kelvin. The intensity units are arbitrary. What is the radiation of the curve same object for 450 K? The original curve with a dashed line here. This, so for this for 13, look at here, this is that intensity is reduced, mostly near to half. So this is option A. Next question. Star X has a luminosity L and an apparent brightness B. The star X is the distance d from Earth. Star Y has the same apparent brightness as X but is 4 times more luminous. What is the distance of star Y from Earth? So it is 2 times increase because distance is 2 times. What is the distance between star 2? Because here be the x distance d from Earth, the Y has the same apparent brightness X but 4 times the more luminous. 4 times more luminous means 2 times the distance. That is the square of the distance is the luminous. That variation of luminous is the square of the distance between them. That means here 4 times means this distance is 2d. Therefore here distance is directly proportional to luminous square. Now luminosity is proportional to d square. By d square. Next one, 4 identical resistors, each of the resistance R are connected as shown. Here, what is the effective resistance P, the terminal P and Q? First, these 3 resistors are in series. That combination is parallel with this resistance. So, we have to calculate by first these 3 resistors, effective 1, resistance effective 1 equal R plus R plus R. These are series, that is 3R. This 3R resistance is parallel with R. Therefore, effective resistance 2 equal 1 by, because it's a parallel, 1 by effective resistance, so equal 1 by R plus 1 by 3R equal 3R, 3 plus 1, 4 by 3R, which is 1 over effective resistance 2. Then reciprocal effective resistance is 3R over 4. That is option A. Next question. A conductor X is connected to cell of EMF E. A power 16 watts is dissipated in X. Conductor Y is made up of same material with the same diameter but X but is twice the long. Both cells have the negligible internal resistance. What power is dissipated? Here the resistance of the length resistance is more in Y. So it consumes more current because its resistance is resistance of the resistance is directly proportional to the length. So we have the calculation is like W, that is power, that is watts energy is V squared by R, that is watts W equal to R squared. Then for X 16, for X is 16 watts. 16 watts equal V square W. You can put E squared because EMF is, we can write E squared by X, resistance is X. For Y resistance, power equal same V squared by R, that is 2E the square by 2X because length is twice. Therefore 4E squared over 2X is 2 E squared by X. It is so 2 times more than 16, that is 32. 32 watts. It dissipates 32 watts. Next one, two containers X and Y are filled with an ideal gas of the same pressure. The volume X is 4 times the volume of Y. The temperature of X is 327 degrees Celsius and the temperature of Y is 27 degrees Celsius. What is the amount of substance X over amount of substance Y? Here PV equal to MRT, P equal to for 1 mole RT. Then generally you can write P1 V1 equal RT1 here R equal P1 V1 by T1. Then generally you can write Rx X container Ry the amount of gas in Y container, that is equal P1 V1 by T1 into the reciprocal T2 by P2 V2. Here both pressure is same, P1 and P2 same. Then we will convert temperature in terms of Kelvin. Therefore V1 over 327 plus 327, 373 plus 327 plus 273 to convert Kelvin into T2 is the temperature 2 is 27 plus 273 converted as Kelvin over V2, that is V1 by 4, because the container, volume of the container, the volume of X is 4 times the container Y. So second container is V1 by 4. So in that V1 by 600, simplifying this 27 plus 273 is 300 over V1 over 4. This is 4 over 2. 2. That is option that for amount of substance in X over amount of substance in Y is 2. Option C. Question number 18. An electromagnetic wave has a wavelength that is about the size of the diameter of an atom. What region of the electromagnetic spectrum does the wave belong to? Here, wavelength of X-ray, this X-ray is the option correct, since wavelength lambda of X-ray is about to 60,000 nanometer. This is approximately atomic size, atomic diameter. It is mostly equal to atomic diameter. So wavelength of X-ray is equivalent to atomic diameter. So option X-ray is the answer here. Next question. A particle undergoes simple harmonic motion of period t. At time t equals 0, the particle is at its equilibrium position. What is the t when the particle is at its greatest distance from the equilibrium position? Suppose pendulum is example for simple harmonic motion. It's a mean equilibrium position. It goes like then this is a point here. Every quarter it have t by 4. 3 by 4. Here t by 4, t by 4, t by 4. So for extreme position is here maximum position. Therefore t by 4 plus t by 4 plus t by 4. Totally 3t by 4 is that. What is the particle at the greatest distance? What is the time for the particle in greatest distance? Next question. Diagram shows the variation of the position of the displacement of a standing wave formed on a string. Diagram 2 shows the variation with the position of the displacement of traveling wave. This is the first one is standing wave, second one is a traveling wave. So what they are asking now, the point PQ, RS are points on the string PQ and RS. What is the phase difference of P and Q and the phase difference of R and S? Here standing waves occurs only when the phase is different. When phase difference is 0, phase difference 0, here this traveling wave phase difference is 90. So 0 and 90 is the 0 and 5 by 2 is the correct option. So C, because this standing wave, this is a traveling wave. Next is the mass 0.25 kg hangs from a spring of spring constant 4 Newton per meter. What is the natural frequency of the oscillation of its system? Here, natural frequency F equal 1 over 2 pi root of k over m. 1 over 2 pi root of k is spring constant is 4 over mass is 0.25, which is equal 1 over 2 pi 4, 1 over 0.25 is so 4, so which is equal 1 over 2 pi into 4, 2 over pi, because 4 divided by 2 is 2, 2 over pi. 2 over pi is approximate 0.64 here. Option B. Next question. Here, the light from the monochromatic source is incident on a single slit and the resulting diffraction pattern is viewed on the screen. The graph shows the variation of intensity with the distance on the screen. Here, the intensity of the source remains the same. The width of the slit is increased. Which graphs correctly shows the variation of the intensity after the change. The original curve is shown in dashed line. Here, this is actually doubles because slit distance is increased by 2, then intensity is same, is increased by 2. So its option is D. Next question. A monochromatic light is incident on a diffraction grating. The diffraction pattern from the diffraction grating is then formed on a screen. Only the central maximum and first order maximum can be observed on the screen. Central maximum and first order maximum. What change will allow the second order maximum to be observed on the screen? You have to make slit adjustment. For that is reduce the number of lines per unit length of the diffraction grating. Reduce what changes will allow the second order maximum to observe on the screen must be reduce the number of lines per unit length of the diffraction grating. Next, a solid metallic sphere is positively charged and isolated from all other charges. The electric potential due to the sphere is constant inside the sphere. The electric potential is because isolated sphere cylinder, isolated sphere, charged sphere, it's a constant inside the sphere. Now other option is not. Then a planet orbits the sun is an elliptical orbit moving the direction like at the position shown which quantity is decreasing for the planet is gravitational potential energy is decreasing. Here acceleration, other things, angular momentum increasing, kinetic energy is not optional. That's here gravitational potential energy is increasing and gravitational potential energy is decreasing. This is a D option. Next, question number 26. A long parallel wires of P and Q are distance D apart. They each carry a current, a magnetic force per unit length F acts on P due to Q. Then look at here, this distance is varied double. What is the magnetic force per unit length that acts P due to Q after the changes? Here, because it is Distance is doubled means it is 4 times reduced because this square law. That means here intensity, the current between this two line here, two line is because this is I and I by 2. So distance is 2, it means it reduces 4 times. That is option B. Because this 2 times reduced, but current is here I by 2. So another 2 times reduced. Totally 4 times reduced. F by 4. Then P is the point in the uniform electric field. What is the direction in which the electric potential increases at P? Here, electric potential going like it increases. So option B. A planet X and Y orbit the same star, that is a single star, planet X and Y orbit it. The average distance between the planet X and the star is 5 times the greater than the average distance between the planet Y and the star. What is the orbital period of the planet X and orbital period of planet Y? This is by using, look at here. This is a log t square is directly proportional to R1 cube. Then by using the relations T1 square by T2 square is equal to R1 cube over R2 cube R1 cube, which is equal 5 R1 by radius is 5 times R1 cube. So which gives time ratio is equal square root of 5 cube. So option D. Then next question. A rectangular conducting coil rotates at a constant angular velocity in a uniform magnetic field. The rotation axis of the coil is perpendicular to the field. So at one instant, the plane of the coil is at an angle theta to the direction of the field. The magnitude of the EMF induced in the coil is it never zero at a maximum when theta equals 0 and R 180. So this is here at a maximum theta equals 0 or 180. That means this coil is rotating at theta equal to 0. It cuts maximum area on line of the uniform magnetic field. So this option is B. A spherical planet has a radius R0. The graph shows the variation of the gravitational potential due to the planet with the distance R from the center of the planet. Look at here. This R is varying. Gravitational potential is varying like. What is the escape speed of the from the surface of the planet? Here, escape velocity V equal equal to Gm over 2Gm over R. That Gm over R is called gravitational potential. Gravitational potential. Therefore, here we have 2 into 5, for this is 5 here, for R0, 2 into 5 into 10 raised to 6 given in the graph. So which is equal square root of 10 into 10 power 6, because square root of 10 is approximately 3.2 into 10 power 3, because square root of 10 power 6 is 10 power 3. So option is C. Then next question. A charged rod is brought near an initially neutral metallic sphere without touching it. When the sphere is grounded, that is earth, there is an electric current for a short time from the sphere to the ground. Electric current short circuited here, that's earth. The ground connection is then removed. What are the changes? Charge on the rod and the charge induced on the sphere when the connection is removed is here charge on the rod is positive and charge induced on the sphere is negative. Option C. Next question. A positive point charge of magnitude 1 microcoulomb and the point charge Q are separated by a distance d. That electron is placed at a distance d from plus 1 microcoulomb charge. The electric force on the electron is 0. What is Q? Here Q is minus 4 coulomb. By calculation of that is, we have to use the formula. F is proportional to Q1 Q2 by R square. So we have this 4. Next, minus 4, we have the option Q is minus 4 microcoulomb. What is the sequence of the evolution of a main sequence star of about 2 solar masses? 2 solar masses is giving the sequence of evolution of first always it's big. First it is a red giant, then planetary nebula, then white dwarf. Finally white dwarf. So here 2 options are white dwarf, but the starting point is red giant. Red giant, planetary nebula, and white dwarf. Option B. Then the diagram shows the emission spectrum of an atom. So look at here, this increasing wavelength. Which of the following atomic energy level models can produce this spectrum? This is the energy model. Option A. Question number 35. A proton of wavelength lambda scatters off an electron at rest. The scattered photon has wavelength lambda days. What is the fraction of the incident photon energy that gets transferred to the electron? That is here. This is the formula. Remember this, lambda s minus lambda by lambda days. Option D. Next one. 3 statements about a nuclear fission reactor are: the heat exchanger transfers energy from the fuel rods to the moderator. No. Then it controls rods must be good absorbers of neutron. Excess neutron must be absorbed by the control rods. Third one, the moderators must slow neutrons down. So this 2 and 3 is correct. So option C. Next, Hertzsprung result diagram shows the two stars X and Y. Then here these are the temperatures in Kelvin, 40,000 and 10,000 and 2,500. Now what is the radius of X over Y? Radius of X over Y. Here this rule that Y is L luminosity is equal to 4 pi r square t power 4. From this R1 two stars radius R1 by R2 is proportional to 10,000 or 4 temperature, here 40,000 or 4, which is further because R1 by R2 equal. Now I can write because it is the ratios 1 power 4 by 4 power 4, that is the square here. Therefore R1 by R2 equal square root of 1 by 4 is equal square root of 1 by 4 power 4, it is equal to 1 by 16, because 4 power 4 square root is 4 by 2, that is 1 over 16. Option A. Next question. The energy of nth level of the hydrogen is given by E0 over n squared minus. What is the frequency of the photon emitted in the transition of n equal to 4 to n equal to 2? This is E0 over h into 1 over 4 squared minus 1 over 2 squared. E0 over h 1 over 16 minus 1 over 4 is equal A0 over h 16 1 minus 4. That is 3 over 16 A0 over h. Option B. Then question number 39. A monochromatic light of a frequency f1 is incident on the surface of metal. The stopping voltage for this light is V1. When the frequency of the radiation is changed f2, the stopping voltage is V2. What is the quantity of V2 minus V1 over f2 minus V1 equals? Here stopping voltage is, by law it is stopping voltage is proportional to photon frequency. Therefore, So this V2 minus V1 over F2 minus F1 is after doing with that your formula is V2 V1 plus E over H. By simplifying, we'll get then which gives option B after simplification. Next one, an alpha particle, that is 2He4, of initial energy 5.5 mega electron volt moves towards the center of the nucleus of the gold 197, that is 79 AU 197. What is the distance of the closest approach? The closest approach formula is D equal to Z, atomic number Z, E square for electron 1 pi epsilon 0 K. By using this formula, we'll get what this distance is, nearly about this 4.1 into 10 power minus 14 meter. So far we discussed a lengthy paper of IB Diploma Physics. We have done. Please subscribe our YouTube channel.